All right, so we are going to go through this assignment as assignment 5, no 1. It was written in 2021. All right, it was for 2021, guys. So the question says, name each of the following coordination compounds and determine the oxidation state of the metal ion. So you need to show your working how you have found those things. All right, so what you are going to do here is we are going to name these compounds and also showing the oxidation state of each of these compounds. So without even wasting our time, shall we start? Okay, so here are the compounds that we have. So we'll start with the first one. How do we determine the oxidation state and also just naming these compounds? All right, so say some tricks on how to name these ones. Okay, so suppose for the first one we have we have cobalt there. All right, we have cobalt, we have ammonia there. All right, we have also H2O. All right, then we have cyanide there. All right, then in cross like that, then we have chlorine there. Okay, so what we do here is we name these ligands in alphabetical order. Okay, then the rest will be just named without even considering the alphabetical order. So the first step that we need to do is to find the oxidation state. So how do we find this? So we'll say we'll say this cobalt is our metal, central metal ion. So it's the one we're interested in. So I'll say I'll put this value as X. All right, then ammonia is neutral. So what I'm going to do is I'll say it's having the charge of 0 plus, then 0 times that 4 we have there. Okay, then inside there again we have H2O, right? So we say plus H2O. So our H2O now again is having 0, all right? Then plus our cyanide there is having -1, okay? Then this chlorine here we have is also having negative. Now there are 2, so it will be -2. So the overall charge of this compound is equals to what? Is 0. We have 0 there on top. So what we do here is we'll say X, all right, minus this minus that is -3, then is equals to 0. So say X is equals to +3. So this cobalt here is having the charge of 3. So say cobalt 3 plus, like that. So this is the oxidation state of this guy cobalt. So now naming this cobalt, we'll say we have according to alphabetical order, we have groups of ligands such as amine, we have water, which is aqua, we have cyanide. All right, so in alphabetical order, all right, so we have amine there with double M and we have aqua there. All right, so we can see the first thing that we'll start, they start with A as well, both of them. So what we'll do is we'll say ammonia, all right, which is amine, then we have double M there and also we have Q here. So we can see M comes first in alphabetical order than Q. So we'll name amine as the first group. All right, so amine will be our first group. So say since there are 4 amines there, we'll say tetra. All right, tetraamine, all right. So say tetraamine, then we have aqua now, all right, so which is water. So we say tetraamine aqua. All right, so tetraamine aqua. So this is now our aqua. It is just 1. If it was 2 there, I would have written diaqua, something like that. So now that we are done with what is inside, so we are remaining with the cyanide. So cyanide as a group is cyano. All right, cyano. Then we bring now the metal. All right, this is outside. So it's having primary valence. So we bring now the metal now, which is cobalt. Okay, so we light cobalt, then the charge of cobalt is what? 3. So light cobalt 3 like that. Then there is another outside thing here with primary valence, that is chlorine. So it's dichlorine because there are 2 chlorine. So say or just say chloride. All right. Okay, chloride. So that's a group, a molecule. I mean, yeah, that's a molecule. So then the other thing that we are going to do here is we'll come to name the B. Okay, so how do we name this one? We'll say we'll first define the oxidation state. All right, so after finding the oxidation state, then we'll be able to name the compound. So the compound is having Na, all right, then MO, which is molybdenum, then oxygen there, which is oxo as a group, then chlorine 4 tetra. Okay, so we'll find the oxidation state. This sodium is having what? The charge of 1, so that's 1. Then plus this molybdenum that we want is now X. Then plus our oxygen is having what? -2. All right, that's the charge of oxygen as the valence. Then for chlorine we have -1, then times 4, that will be -4. This over is equated to 0. So what we are going to do here is we'll say we can see that no, here it's supposed to be 2. Yeah, it's 2 there. So here it will be also 2. We can see this and this goes, so we'll say X is equals to, that one will go there, that will be +4. All right, so meaning that our compound is charged, I mean our metal is charged +4 like that. So how do we name now? So we have sodium there, so we'll start with this, what is outside there on the left, so we call it sodium. Okay, so we name it as sodium. Then how many? All right, we come to ligands now. We only have how many ligands? We have how many ligands? We have chlorine there and also oxo, and also we have only chlorine and the oxygen, which is oxo as a group, then chlorine, chloro. So which one comes first in the alphabet code? Is of course C, which is chloro. All right, so there are 4 of them. So I'll say sodium tetra. So I'll say tetra. Tetrachloro, all right, chloro. Then we have what? We have oxo, all right, as a group. Oxygen is called oxo. Then we're done with oxo and everything like that. So now we are bringing the metal. All right, the metal is molybdenum. All right, so molybdenum, in fact I'm not supposed to put I. So it's molybdenum, then you put now the charge, I mean the charge of the metal, so that is what? 4. So I'll write it like this. So this is the name, sodium tetrachlorooxomolybdenum. So then for C again we are going to find again the same stuff. We'll find the oxidation state. So we have sodium there again, sodium, we have aluminium there inside, then we have hydroxyl there. All right, so hydroxyl is having 4 now. All right, so how do we name this one? Of course we need to find the charge of this metal ion. So here we have X. All right, I mean for oxygen, for sodium we have 1, then aluminium we have X, then this one is having negative, so it will be -4, then is equals to, the overall is 0, so X, our X will be, when you add that, will be now +3. All right, so now our charge, our compound is charged 3. So how do we name this one now? So we'll see, we can see here is that is C. So we can see that we only have this sodium. So you start with the same sodium, all right? You start with the same metal which is on your left. So that's what we call cation. That's a part of cation. Then from there, then you bring now the ligand that you have. So the ligand we have is oxo, okay? It's hydroxyl. So as a group, it will be hydroxyl. Then it's not just supposed to be hydroxyl. Remember, there is also 4 here. So what you are going to do here, we'll say tetrahydroxyl. So we'll say tetrahydroxyl. So after lighting tetrahydroxyl, we have aluminium. If this compound was charged something here, this was going to be aluminate. All right, so the moment the compound is charged to a negative thing, it's called aluminate, cowpate, ferrate. All those stuff will be used when it is negatively charged. Now that it's just neutral, so we just bring the same aluminium. So we'll say aluminium 3. All right, so the name is sodium tetrahydroxyl aluminium aluminium 3. So I'm not writing this 3, I'm writing 3 like this. All right, so it's not an ion, so we'll just leave it like that. That's the reason why it's not charged. So then the other thing that we'll talk about is C, then we'll go to D. So what we need to know is, again, we need to find the oxidation state. So finding the oxidation state for D, we have chromium there, all right? Then we have H2O there inside, all right? Then 4, then we have chlorine there, all right? 2, then outside there we have again chlorine, all right? So how do you find? We need to find first the oxidation state of chromium. So that will be our X to say. Then then this one, water is charged to 0, so that will be 4 times 0, which is 0. Then plus we have minus there, which is minus 2. Again outside there, all right, it's again minus 1. So the over is equals to 0. So we'll say X is equals to, now this will be plus 3. All right. So that is in now the oxidation state of chromium in this compound. So that's how you find it. So we'll say, how do we name now this compound? So we said we name them according to alphabetical. Water is aqua, then chlorine is chloro. So how do we start now? We start with the same aqua. So aqua is now 4 groups. So I'll say tetra aqua. Tetra aqua, all right? Then dichloro. Dichloro, all right? Then what else? What else are we supposed to do? So we have dichloro, right? Then there's also another chlorine. So this chlorine will put first the metal, so which is chromium. So I'll say chromium. Chromium what? So chromium, we had what was the charge? What was the charge? The charge was 3. So say chromium 3, then chloride. All right. So because there is chloride there at the end, so we'll say chloride. Okay. So what about for E now? So looking at E, we have potassium 4 there, then nickel. We have cyanide there, all right. Then we have also it's done like that. So what we need to do here is we find again the oxidation state of nickel. So say nickel will be now X, then plus here it's now 4, all right. So it's positive 4. Potassium is charged as positive 1, so that will be now positive 4 in total. Then we have here cyanide is negative, right? So this will be just -4 like that. Then the overlay is 0. So even here, so x is equals to 0. So this nickel is not charged. Okay, so the nickel is not charged. So what we'll do here is we'll say we're going to say nickel is not charged. So now let's name it. So we have potassium there, right? We won't name it as the tetrapotassium. No, you just start with the same element the way it is. So you say potassium instead of tetrapotassium, you say potassium. That's all. So say potassium. Okay, so now coming to the ligand, we have cyanide. All right, so it's now 4. There are 4 in total. So we'll call them as tetracyano. Okay, so tetracyano, then we come now to the metal, which is nickel. So you just say nickel. All right. Okay. So if this compound was charged, let's say negative, and we had the same charge here, it was going to be nickelate. All right. So but you end here as nickel. All right. So